I'm going to switch over to a coverage whirlwind form of sort of a high-level summary of Catlab. So what is that? I've give reference to the fact it's a categorical computing platform. It's one of two such platforms that have come out of the Topos Institute in Berkeley, California. The other being Catlab. Catlab, as noted, is based on programming language Julia and really exploits that to try to take advantage of, on the one hand, declarative, domain-specific mini languages, having those on the one hand, and type-based specialization that allows for something close to kind of hard-coded performance. And as I noted, it's at the heart of the algebraic Julia ecosystem. I will note, I'm not going to talk much about it, but there was some interest expressed in one of the surveys that Catlab is based around something called Catlab. And Catlab, you can think of it as like the heart of Catlab. It's generalized algebraic theories lab. This is based on the notion of generalized algebraic theories due to Cartmel, if any of you might have come across that. And at a computational level, it's related to ideas from dependent type theory. GATLab allows expression of not only classic algebraic theories, like might be involved in the theory of groupoids or monoids, groups and rings and semi-rings, etc. It further allows for description of some structures with added power, including categories. GATLab here supports a variety of doctrines, some of which you'll see featured within this session, like theory schema. But it also offers theory pre-chief, theory category, pre-symmetric monoidal categories, pointed set categories, etc. And the idea is these doctrines define sort of broad areas in which you're afforded certain bells and whistles. And you can create a theory for a particular area within one of these doctrines, like within theory schema. And then you can create particular models of your theory that adhere to those properties. And these can be symbolic models or models defined using built-in data types using Julia. GATLab is used to define many of the primitives that we're going to be using within our sessions here. So when we say categorical, you may be wondering of what are we speaking? Well, these are some, what's shown in bullet points here, in a somewhat abusive fashion, given your distance from the screen, is a variety of structures that are reified. They're turned into kind of objects that you can manipulate, that you can refer to, that have certain properties, can be mapped to certain operations associated with them in Catlab. And I'm not going to list them, right? But they include maybe more fundamental things in categories, in category theory, like categories themselves, functors, and types of categories like preorders and lattices, which have meets and joins, etc. And a variety of set-like categories like fin set, skeleton, and fin set. Some of these will be names that mean something to some of you here, and some less so, probably. But also more derived structures, things like slice categories, for example, which allow us to take a category and incorporate some extra information in it that can allow us to kind of reason about certain types of structure preserving mappings within a given category, mappings that preserve certain maps to certain objects in that category. So can be very helpful to sort of label things in categories. So going from a graph to a weighted graph, for example. And there's higher level gadgets, things like structured co-spans, directed and undirected wiring diagrams, and tools like that that allow us to sort of build up higher level structures. I will say for all C sets and all these Copree sheaves and Atchets, AC sets, we have these categorical operations that are forwarded. If I use the term that a Copree sheaf is a topos, maybe some of you will, like, that will be something that's meaningful to some people. A topos, you know, is a nice place to do logic and to do math essentially with certain ranges of structures. All C sets are for a given category C or associated with a topos, and therefore we can take products and co-products and pullbacks and pushouts and pullouts and various types of limits and co-limits. We have exponential objects, which again will be terms meaningful to some of you and not to others. For this reason, C sets are at the heart of what you see in Catlab. So so these are sort of things that you can point to. They're reified, they're turned into structures in Catlab. What can we do with them? What operations can we undertake? Well, you can do things like composing morphisms, these mappings, these structure preserving mappings called homomorphisms. We can compute what are called representable functors, which are natural building blocks for building up larger structures with Copree sheaves. We can take categories of elements of a Copree sheaf, which kind of, amongst other things, gives us a way of visualizing different types of structures and reasoning about their pieces in a way that applies to any C set. We can compute these universal construction limits, co-limits, perform categorical rewriting. We can ask whether morphisms are monics or epics, etc. And we can ask whether a given transformation that we wish to propose is a natural transformation. For some people, these will be more meaningful utterances. We're going to go and look at code where hopefully I'll provide enough commentary that you'll start to get a feel. If a homomorphism just sounds like a big, scary word right now for anyone here, we'll see lots of examples of them, and you'll find that it's a very natural, powerful notion, natural in a vernacular and in a mathematical sense that has a lot of intuition associated with it. We'll see representables, and we'll see examples of morphisms. So apologies for needing to speak to different audiences. I have in here a set of resources, and I'm just going to gesture at them with the exception of saying that there's really active communities associated with these areas of Catlab within Julia and the category theory community as it relates to Catlab. And there's two Zulips. I don't know if anyone here is familiar with the use of Zulips for online discussions. It provides an interface that can allow for sort of rich community interaction with discussion about topics and sharing of different types of resources. There's two Zulips in particular where there's a lot of discussion that goes on in Catlab related matters. And Xiaoyan and I are on there all the time, but so are many of the other contributors to the project and thought leaders that have made these technologies possible, like John Baez is, unbelievably active in these things. For those who are interested more from the manuscript side, there are two foundational manuscripts, I would say, related here. There's one on categorical data structures for technical computing and compositionality that in some ways articulates the program that the general program at which Catlab is aiming to explore. It explains the use of attributed C sets and C sets within this area. And secondly, there's this other paper with a somewhat different emphasis on scientific computing with Catlab and a predecessor called semantic models that came from James Fairbanks' group. I noted that the algebraic Julia ecosystem is large. Each year, more projects gets added to it. Xiaoyan is behind several of these projects, like state charts and stockflow.jl. and have contributed to algebraic ABMs and others. These are some of the projects that are reasonably active in algebraic Julia, with the exception of algebraic Petri, which is a little bit old, long in the tooth right now, and you really need some updating. Algebraic ABMs is in an early stage, but it's quickly taking form and has a lot of useful functionality already. Okay, so that's a little bit of a high level on algebraic Julia and Catlab. Any questions at a high level that people would like to bring forward before I start diving into taking a very concrete look at how this plays out in terms of specific functionality? We'll see a lot of examples. Any questions that I could help address? And again, apologies for the different levels at which I'm trying to speak to the audience. We'll have lots of material at different levels coming up. Are we good? Okay. So I'm going to stop this